Hi guys, we're going to be jumping into chapter 1 here, and we're actually starting with 1.2, and we're going to break this into two different videos so they're not as long. So this one's going to be talking about linear equations and rational equations. So your objectives are to solve linear equations in one variable, solve linear equations containing fractions, solve rational equations with variables in the denominators, which is the bottom of a fraction, recognize identities, conditional equations, and inconsistent equations, and then we'll solve applied problems using mathematical models. So those will all make sense as we walk through this. So the definition of a linear equation is that it has one variable, and often we use x, but you can use other letters. The x is in an equation that can be written in the following form. And this form is ax plus b equals 0. And the a and the b have to be real numbers, and the a cannot equal 0, because if you had a 0 in front of the x, then there would actually be no x left. So that a is just some constant number, and we'll be looking at examples coming up here. So we're going to start by learning how to generate equivalent equations. So an equation can be transformed into an equivalent equation by one or more of the following operations. And you guys have done a lot with equations, one-step, two-step equations, things like that. So these steps should look familiar to you. So step 1, you're going to simplify an expression by removing grouping symbols. Let me change this font, make it a little smaller. And combining like terms. So if you have two different sets of x's, you could put those together. Step 2, you're going to add or subtract the same real number or variable expression on both sides. So if you subtract 5 on one side, you have to subtract that same 5 on the other side. And then you will multiply or divide, and I'll abbreviate here, by the same non-zero quantity on both sides. So if you divide by 4 on one side, you have to divide by 4 on the other side. And then step 4 is you can interchange the two sides of the equation. So what that means is if you have x equals 9, that would be the same as 9 equals x. So if you like the x to be on a particular side, you just rearrange the whole equation. And again, these are those steps that the first step, you would remove any grouping symbols and combine like terms. The second step, you're going to collect all the letters or variable terms on one side and then put all the numbers on the other side. So for example, you'd want to get every x to the left side and all your other numbers without letters onto the right side. And then you're going to isolate the variable. That just means get the letter by itself and solve it. And then you always want to check the solution in the original equation. So what I like about equations is you can always double check your work by plugging the number you found back into the equation. Okay, so let's start here with an example. So 2x plus 3 equals 17. So we notice there's only one set of x's here. So there's no x's we need to move around. But we need to get this plus 3 over to the other side. So the way to do that would be to minus the 3 to make 0 and minus the 3 on both sides. So if you think of the two sides of the equation, I subtracted 3 on both the left and the right, and that keeps it equivalent. So now on this left side, I have 2x is the only thing left, and then I have 14 on the other side. So 2 times some x is 14. To find that, you can divide by 2, and that really makes a giant 1. So you could just say x instead of 1x equals 7. And then to check it, our original equation was 2x plus 3 equals 17. So I'm going to replace my x with the 7 I just found. and see if it's a true statement. 2 times 7 is 14. 14 plus 3 should be 17. So we're asking, do these equal? Yes, they do. 17 equals 17, so it checks out correctly. Okay, let's try another one. So here's our x term. If we think of the two sides here, we need to move this 5 over here. So I'm going to minus it because we're trying to get the letter isolated completely by itself. That makes 0, so that's good. And that gives you 24 on that side. And we're left with 4x on the left. Then we can divide by 4. That makes 1x. Divide by 4. So we're left with 1x equals 6. Let's go ahead and check that. 4x plus 5 equals 29. Replace the x with the 6 that we found to see if it's true. 4 times 6 is 24. 24 plus 5 should be 29. And it is. Okay, now we have a lot more involved with this one. So when we're talking about grouping symbols, that could be parentheses, brackets. So if we look at this one, we can actually apply the distributive property, and I usually draw arrows, so I remember I'm taking this entire x minus 3 and multiplying it by 2. So really now I'm going to have 2 x's, then I'm going to have 2 sets of negative 3, which is negative 6. So I just follow the arrows and multiply. Parentheses mean multiply. I still have this minus 17. I have the 13, and now here, I'm going to draw my arrows again, so I multiply this entire quantity by negative 3. Be careful, that's a negative. So I have negative 3x, and negative 3 times 2 is negative 6. Okay, now we can combine our like terms. So that means put common things together. So let me look at my two sides here. On the left, there's no other x's, but I could put these two together, these normal numbers. Negative 6 minus 17 is negative 23. Then I have 2x. Okay, over here, I only have this x, but I can combine my 13 minus 6 to make 7. Then tag my negative 3x behind it. And again, you could have the negative 3x first. Negative 3x plus 7 would be the same thing. Our next step, we need to try to get our letters together on one side and our normal numbers together on the other. So usually I start with the letters and I move the smaller letter. So my smaller letter is actually a negative 3x, and I want to move it over to the other x. So to get rid of a negative 3x, I would add 3x to make 0. But if I add 3x on that side, I have to add 3x on the other side to keep it equivalent. So now I have 5x minus 23 equals 7's all I have left over here. And now I'm going to move my normal numbers over to the right side. So I'm going to add 23 to make 0. Add 23, that makes 30. And all I have left on this side now is my 5x. And finally I can divide by 5 on both sides. That gives me x equals 6. Now I'm not going to check this one, but you definitely could. You would just go back in and you would have to put a 6 here and a 6 here, and it should check out. If it doesn't check out, then you'll know right away that you did something wrong and you can go back and retry the question. Okay, let's try another one. So this one, I have one set of parentheses. So I'm going to apply my distributive to get rid of my grouping symbols. That'd be 3x minus 18 equals, now this is a 1x here, so 6x minus 1x is 5x. Okay, so you have to be careful here. You need to move your letters to one side, but if I moved this 5x, then I would have nothing left on the right. So instead I need to move my 3x over. So to get rid of a positive 3x, I would subtract 3x. That makes 0. So I'm left with a negative 18 equals 2x. I can divide by 2. That leaves me with negative 9 equals x. Or you could say x equals negative 9 if you like the x to come first. Either one of those would be right. And I will show you how to check this one. So I'm going to take my original equation and I'm going to replace every x I see with a negative 9. So this becomes negative 9. Bring everything else down. This becomes negative 9 minus this becomes negative 9. So I actually have a double negative here. So that turns into a positive. So this one you can actually do your order of operations. You can put together what's inside the parentheses, or you could do distributive. I'm going to just put these together. Negative 9 minus 6 is negative 15. I still have to multiply by the 3. 6 times negative 9 is negative 54. And I have a positive 9 there. So 3 times negative 15 is negative 45. Negative 54 plus 9 is also negative 45. So that checks out, meaning if I did all my math correct, negative 9 should be the answer. Okay, let's go ahead and end with this fun one. So we have this whole equation. There's lots of fractions. So there's a few ways you can do this. The easiest way that I found is to use the LCD, the least common denominator. So this word common means what's the number that all three of the bottom numbers can make, the 4, the 14, and the 7. So if I look at the three bottom numbers, all of those could make the number 28. They can all multiply into 28. So the trick on these is we can multiply both sides of the equation by that LCD to get rid of all the fractions. And when we're done with fractions, it makes it a lot easier. So what I mean by that is I'm going to take the entire thing times the LCD of 28. So I'm taking this first amount times 28, the second amount times 28, and my third amount by 28. And then there's some kind of shortcuts you can do with simplifying here. So if I look at this problem, the 28 and the 4 can reduce. 28 divided by 4 is 7. So it becomes 7 over 1. So now I'm left with just 7 multiplied by that first amount. All that's left is x minus 3. You could put the 1 on the bottom, but that's not necessary. So we'll leave it like that. Now the next one, 5 over 14 multiplied by 28. So again, 28 divided by 14 can simplify to a 2 and a 1. I'm just pretty much reducing my fractions. So now I just have 5 times that 2 that's left. And let me just refresh your memory if you're struggling with how I'm doing this. So what I just did was I did 5/14 times 28, or 28 over 1, if you want to think of it that way. Your diagonals can reduce. Both of them can be divided by 14. If you divide by 14, you're left with a 2 and a 1, and then you're just left with 5 times 2 is 10. So that's where this 5 times 2 is 10 comes in. Okay, then our last amount, I have a 28 on top and a 7 on the bottom. I can divide both of those to reduce down to a 4 and a 1. So now I'm left with, now don't forget this subtraction sign here. I have a 4 times my x plus 5. And now we can start simplifying. So if I distribute, that's 7x minus 21. Bring down my equal sign. I already said 5 times 2 is 10. Negative 4 times x is negative 4x. Negative 4 times positive 5 is negative 20. Now over here, I can combine my 10 minus 20 is negative 10. Then I still have my negative 4x. Bring everything else down that I haven't touched yet. Now I can get my letters together. Again, I try to move the smallest one if possible. So I'm going to move my negative 4x by adding it to make 0 to both sides. So now I have 11x minus 21 equals negative 10. Next, I can go ahead and try to isolate my letter by adding the 21 to both sides. I'm running out of room here, so let me finish it over here. So I'd have 11x, my 21's cancel, equals negative 10 plus 21 is 11. And we ended up with a nice number, no decimals, no fractions. So 11 divided by 11 is 1. So that whole thing ends up with x equals 1. And you could definitely check this. You could go and put 1s in everywhere you see an x. You could put a 1 here and a 1 here, and then check to see if your answer is correct. So that's the end of this video. We will go ahead and do part 2 of 1.2 in the next video.